Hi, everyone. So I'm Gillian Mollod, this is my first time coming to this conference. I'm really excited to be here. I'm excited to be a speaker. I work for a company called Intercontinental Exchange. Our acronym is ICE. It's not the greatest acronym to have right now, so I like to say to people, I work for ICE, but not that ICE. But yeah, so I sit on the product team in our fixed income and data services in our ICE climate team. So my focus is on our global physical climate risk model and also our nature and biodiversity solution. And this is a solution that we provide to institutional investors. My background is in ecology and environmental science. I started my career in the nonprofit sector. I worked for over 10 years for a land conservation organization focused in the Hudson River Valley. And that's where I got started in geospatial analysis. I really started their geospatial program and worked there for years as their GIS specialist. Yeah, so I'm happy to be here today.
Thanks for attending. Dovetailing into that, you've worked at the intersection of geospatial analytics and climate strategy for years. How do you define GeoAI and what makes it uniquely powerful to understanding systemic and climate risk?
Yeah, so as I mentioned before, I got started right in the nonprofit space. And one of the things that is kind of interesting is sort of the trajectory that I've seen the geospatial space take in the last 20 years. And so when I started, it was something that like typically sat within governments, local governments, state governments, nonprofits. It was not in the financial sector, geospatial analysis. Also, data was updated very infrequently. Raster data of 1 kilometer resolution would have been considered high resolution. So really what I started, when I started my career in GIS, I was working with what would seem like archaic data in today's day and age. When I moved to the financial sector, which was in about 2018, the changes that I saw from the early 2000s to 2018 with geospatial data were really incredible. But the changes that I've seen in the last 5 years have been monumental. And a lot of that is being driven by AI. I mean, we've had improvements in satellite data and radar technology, but really, GeoAI is what's, or AI is what's really, jump-starting this technology boost. I heard somebody recently say, we don't really have a data problem anymore. We now have a data science problem where we're trying to keep up with technology. And so when I think of GeoAI, what I think of is incorporating AI into geospatial intelligence to identify patterns and trends in location-based data. The work that I do in the climate space is very location-based. Climate risk is it's all about where you're located. We at ICE Climate, what we do is we use AI mostly to assess what type of building is located on the ground. So in order to really understand your climate risk, you need 3 things. You need to know what's on the ground, what are the hazards that are going to potentially impact that area, and how susceptible is what is on the ground to those hazards. So trying to understand what's on the ground is something that we really do a lot of GeoAI with. And we do that by training a model that takes in location data. So we trained a model on 700,000 assets with known characteristics. And then we use that to determine globally for 1.6 billion buildings what the building type is. Is it commercial, residential, or industrial? Is it low-rise, mid-rise, or high-rise? And then what's it made of? Is it wood, concrete, steel, et cetera? Yeah. So that's a long answer.
No, that's a good answer, right? And so you're talking about earlier how organizations really haven't embraced geographic data, and it's just recently, in the past 5 years, become a thing within the fintech sector. So and they see it as a nice to have. What do you see as a business case for embedding GeoAI into climate finance and risk management systems?
Yeah, that's a great question, and it's something that we think a lot about at ICE Climate, because really we work with financial institutions, and a lot of financial institutions are still sort of not ready to incorporate climate risk data and geospatial analysis into their portfolio managements and investment decisions. They kind of see it more as a risk signal. So, trying to bridge that gap and trying to, help them understand, the importance. And I think, we live in a very reactionary society where a lot of times, financial institutions don't see the necessity until it's almost too late. So really the players who are incorporating climate risk into their financial analysis and who are putting it on their books and using it for portfolio decisions, they're really going to get ahead of the game. And we've already seen this with some of the recent events that we've seen in, floods in Texas and hurricane in Jamaica and wildfires in California. It's climate change isn't just something that's going to affect us in the future. It's here now.
Mm-hmm. And that's one of the things that we have to deal with, right? Because geospatial doesn't move as fast as fintech. So there's a growing tension, and that actually causes a friction between our two verticals, right? And we also don't speak the same language. That's a whole other story. But right now, there's like a competition between scientific rigor and the financial feat of getting data to the financial industry. How do we balance these two without losing trust between the two data sources?
Yeah, I mean, it's an interesting thing because, like, in the space that I work now, I work with a lot of people who've been in the financial world for many years, and I work with a lot of researchers and scientists. And the scientists, they have these methods that they've been following for years. A lot of them come from academia. They're used to, a long research process followed by a peer review, and then, it takes a while for things to publish, and it's okay to move slow, whereas in the financial world, everybody's looking at things in a monthly, quarterly, annual basis. And getting those two to sync up is sometimes a challenge, and because you want to keep the scientific rigor in your methodologies, but you also want to get the product out. So I think there is a lot of tension. That's a good use of the word. And I think one of the things that potentially we'll see with the incorporation of GeoAI is making more timely insights and being able to sort of maybe not meet those monthly or quarterly, but those yearly financial statements.
Yeah, agreed. So what do you think the biggest misconception about GeoAI is in the climate space, especially in fintech, like investors and VCs and that kind of things?
So this is an interesting question because I think a little bit the misconception is a little bit around the fact that climate models are interesting, right? Because what they're doing is they're saying what's going to happen 10, 20, 30, 40, 50 years from now. And so it's a lot of estimation, it's a lot of probability, it's a lot of uncertainty, and sometimes it's seen kind of as the Wild West, like there's no standardization, it's all estimations, like you're modeling things you don't really know. So now when we say, okay, well, we're also going to bring AI into it, it makes people a little skittish. So finding a balance where you can kind of say, this isn't really the Wild West, this is more standardized than you think. A lot of people are using the same type of models. We're all looking at, what's on the ground, what's the hazard, what's the vulnerability, and how can we use AI to sort of kind of calm some of those nerves and skittishness around it.
Mm-hmm. So one of the things we deal with in the geospatial community is like EO companies are all like trying to get into the financial sector. And they're like, and they deal with precision, not necessarily a temporal cadence. But do you see the Earth observation data or satellite data ever evolving into a financial signal, like a standard risk credit score or risk score?
So Earth observation data is super interesting because, I've been working with it for a while. Like I said, it was like, really low res, not that frequent. Clouds were a big issue. It's interesting, again, because, something that really defense companies were using, governments were using, not a lot of financial companies were using. And like for good reason, because they're just, didn't have the expertise on board to sort of say like, this is how you should use it, or this is the signal you should get from it. when I started in the financial space, this is sort of when companies were trying to get more EO data into the financial institutions. And at the time, I was working for another data provider, and we started talking to a number of satellite vendors, and a number of them would tell us, well, we can count cars in a parking lot, which is, I now find kind of comical because, like, yes, that is definitely great data if you're a retail store and you want to know what time of the year, what time of the day, what time of the week is my most popular hours. But for a large financial data provider, it wasn't a signal that we could use. So I think what I've seen in the last 7 years, which has been pretty interesting, is really, I still don't think the financial world is necessarily ready to take like raw satellite data and process it.
Agreed.
But I think what we're seeing now is we're seeing a growing number of startups and companies that are taking that data and turning it to something that's actionable for financial institutions and coming up with signals. And I think it's going to be really important as AI kind of evolves to say, to meet with financial institutions and say, like, what do you want, like, what's the data points you're missing? And things like supply chain, commodity, like understanding commodity growth and you know, the commodity market and especially around physical risk, like all of that stuff is going to be really relevant. And I think that that's something that, you know, EO data and AI together can be used to sort of solve problems.
Yeah, agreed. But it's funny because we've been fighting this fight for years. It's like, as long as I've been in the geospatial industry, it's like, yes, insurance companies should do this. Yeah, they should, but there's not really an ROI to it yet.
Yeah.
Right. It's hard to navigate those 2 points. Yeah. So climate finance depends on quantifying uncertainty, as does insurance. How can GeoAI bridge the gap between scientific uncertainty and financial decision making? Yeah.
So I think what's interesting is, so climate risk obviously is embedded with uncertainty. It's a lot of, like I said, a lot of probability going into it. We're trying to predict the future. So, I mean, I don't have a crystal ball yet, but so I think what AI can do in this space to sort of to help with uncertainty is that, you know, we use these large global climate models and these big models that are run, and the outputs are huge. There's lots of outputs, and there's lots of different models being run through these global climate models. There's a number of different ones, and the outputs are all different. And AI can really be used to understand those the uncertainty and the variability in the different models. And so, like, if you were to look at flood risk of a certain area, you might say, you know, let's take 10 different flood risk models and find the average. But the flood models might be developed in many different ways. So what AI can do is say things like, you know, this climate model is predicting low risk, and this climate model is predicting high risk, but the difference is that this climate model has better elevation data, whereas this one has better precipitation data. And so understanding sort of the underlying variabilities in the model and what's driving that uncertainty, I think that's going to be huge in the AI space.
Agreed. And also, well, and another thing, kind of dovetailing into that, AI is a black box, and our industry is heavily regulated. As AI is more integrated, how much is that explainability of a model's decision-making process going to affect everybody from like into the regulatory space?
Yeah. No, this is an important question. I think one of the things, like I was saying, like there's a lot of skittishness around still, you know, climate modeling and AI data. And what I found is that when you release a model that has a lot of estimations or modeling in it, you really need to be clear about like the transparency, the limitations, the restrictions. So what, like everything that you're doing, that like, you know, not leaving any gray area, being completely transparent in how you're modeling the data, and then also, you know, just delivering something that's digestible, that's usable. So, you know, sometimes you hear of these models that people create and they try to sell them, but they're so complicated, no one knows how to use them. So finding signals that are really digestible for the financial world is super important in this space.
Yeah, it is. So let's fast forward to 2050, as the title of the symposium is that. What does that world look like in the climate finance space? With GeoAI being like, at that point, it's integrated as like a fundamental layer of everything. How do you, what world do you envision like that?
So, I mean, 2050 is 25 years from now.
Which will go by in a heartbeat.
Which will go by in a heartbeat. But as I was saying, like, I started in this space close to 25 years ago. It's changed so much that, and you know, especially in the last 5 years. And so I think really, you know, we could be looking at a totally different world where, you know, maybe humans aren't making as many decisions. I hope they still are, but you know, I was hearing the other day, my son is applying to high school right now, and one of the we are touring a number of schools, and one of the principals just said that they give less math homework now because kids will use like, you can take a picture of a math problem and then upload it and get the answers. So that was a little bit hard to hear, yeah. So what will the world look like in 25 years is definitely like, you know, it would cause me to be very hypothetical in guessing this, but in my space, what I'd really love to see is I would love to know for every single point on the Earth, what is there and what was there. So like, we have this abundance of data. A lot of it is Earth observation data, but we can tell from 2000 to now how things have changed, and to 2050 that'll even be different. But we'll also be able to tell things like, you know, is it just an empty plot of land? What's the soil? What's the vegetation? Is there a building? What's the building type? I think all of that will be much clearer, and we'll also know what we've done with the climate, right? So we'll know our emissions trajectory, where we are now. Are we going to stay on the same path? Is it going to be a business as usual, or are we going to put policies into place? So all of that will be like better known, and we'll also, if we don't put policies into place and we keep a business as usual approach, we'll have more severe and frequent storms. We'll have more heat waves. We'll have more droughts. And that'll be a different world that we're going to be living in. And we'll have more data on how to understand climate. So climate models might be better, but I think one of the things that I grapple with in terms of using AI and climate data is that, you know, we're building all these new data centers. They're very water intensive. They're very energy intensive. I think as we watch the AI world evolve, we really need to take into consideration our energy use and our water use, because we want to make sure as we try to solve this climate problem, we're not just exacerbating it. Yeah,
the statistic a couple years ago was a single LLM takes 700,000 gallons of water, just in heat. And that's insane to me, right? It's just like, okay, so now what are we going to drink? You can't ask ChatGPT for a soda, right? No, but we're being played off. I appreciate your time. I appreciate your subway ride down the street. And thank you for attending Geography 2050.
Thank you for having me.
And next on stage is Dr. Jerry Gobson.